Welcome back, class. We were learning about the communication systems, and last time we have learned about the building blocks of the general communication system, like transmitter, channel, and receiver. And we learned about the modulation, that what is the modulation, what are the importance of the modulation. So we are going forward, and in this lecture we are going to learn about the frequency bands, that what are the different frequency bands defined by the International Telecommunication Union, how the electromagnetic waves propagate for the transfer of information. Like we learned about the wireless channel, and in the wireless channel the information is transferred using the electromagnetic waves, radio waves. So we will learn that how they are actually propagating for the transfer of information measure and channel capacity. So frequency band, so basically the International Telecommunication Union, okay, they have defined the different frequency bands under different names, like very low frequency, medium frequency, high frequency. So the purpose of defining the frequency band is that different applications can be performed at the specific frequencies. For example, the GSM band, okay, the telephone should work at a particular frequency, the Bluetooth should work at a particular frequency, the 5G application, they must work at a particular frequencies, X-ray applications, satellite communications. So everything should work at a particular frequency so that there should not be interference with the other applications. Okay. So that is the main reason for the regulations. So this is a typical chart for electromagnetic spectrum. You don't have to memorize it. It's just to give you an idea that what are the different frequency bands for the different applications. For example, if you talk about the AM radio, they are typically work in the 600 kilohertz to 1.6 megahertz. So this is the frequency band. Okay, this one. They usually work in this band. This is just the wavelength in meter and the centimeter. Okay, so frequency band is important. Okay, so and if you talk about like the mobile phone, GSM 900 megahertz to 3.4 gigahertz, radar applications 1 to 100 gigahertz, wireless data routers, they usually work on 2.4 gigahertz. Your microwave oven in your home, it works at 2.4 gigahertz. Ultrasounds, okay, TV broadcasting is around this. FM radio 80 to 108 megahertz. So as like we are moving towards high, okay, towards high frequency. For example, here we reach the terahertz range. This is the megahertz range. This is the gigahertz range, 10 to power 9 terahertz range. So different application, for example, remotes, they are usually working in terahertz infrared range. Visible light screening, thermal screening, like if you going to a like for example a mart, they do the thermal screening. They usually done at the 0.2 to 4 terahertz. The X-rays, they are usually done in 10 to power 18, okay, hertz, very high frequency. Baggage screening at the airports, it's usually done at very high frequency also. So like for the different applications, they have defined different frequency ranges, okay, so that each application can perform his operation more appropriately without interfering other one. Okay, so these are just the bands and the different applications for each bands. So usually like 3 to 30 kilohertz, we call it low frequency bands, then very low frequency band, then 30 to 300 low frequency, and similarly the other ranges. Okay, 30 to 300 megahertz very high frequency, and then like super high frequencies like that. Just different bands and the different applications. Again similar picture for the different applications. Now these are the like different frequencies, different electromagnetic waves. Okay, so like if you can see here, if we are going up and up the wavelength, okay, like if this is an electromagnetic wave, okay, this is the frequency, oh sorry, time period, and also this is called the wavelength, right? So basically as like if we are in the hertz range, okay, so we have the wavelength, for example 10 to the power 3 meter, like the football field. Okay, So as we are moving high and high, so here for example, here we get the wavelength of 1 micrometer. 1 micrometer, 10 to the power minus 6. So the wavelength is decreasing with increase in the frequency. So there are different frequencies. Now how these different frequency propagates, or different frequency electromagnetic wave radio waves propagate for the transfer of information. So this is the topic of the propagation of electromagnetic waves. So there are three different kinds of the propagations. The first one is ground wave propagation, sky wave propagation, and line of sight propagation. So we are going to see each one separately. Okay. So basically ground wave propagation is, if you look at this picture, okay, for example, this is our earth surface. Okay. This is our earth surface. And you might have seen the towers which are actually installed at different locations. For example, the mobile towers for the transfer of the mobile signal. So they are usually installed at the different height locations, and we have very high towers. Okay, they have different heights. Okay, so like they are installed at particular location, and their heights is actually adjusted so that they can communicate, their antennas can communicate directly to each others. Okay, this is called line of sight communication. Line of sight, they are inside to each other. Okay, so basically above the earth's surface we have different layers. Okay, like we have troposphere. Like as we move above 10 kilometer we have troposphere, then we have stratosphere which is 10 to 50 kilometer, then we have D layer, E layer, and so on. Okay, so like here, and then we have ionosphere and the other things. Like as we are moving here we have different layers above the earth, and like the aeroplanes, they are usually moving in the ionosphere layer. Okay, and above that we actually have the satellites here. So basically what is actually happening above the earth's surface, we actually have the ultraviolet rays, the sun rays, the cosmic rays. Okay, so when these cosmic rays are coming towards the earth, okay, so near the earth we have the air particles, and when these air particles and the ultraviolet rays interact with each other, okay, so the ultraviolet layers are very strong layers. Okay, they have very strong density. Okay, so they will actually ionize, they will break the air particles. Okay, and that process is called ionization. Okay, so basically you have one positive and one negative ion. Okay, so that is actually called ionization. Okay, so as we are moving towards the earth, okay, because we are having more air particles, so we will have the more ionization. And as we move above, okay, because we have more ultraviolet rays, their density will be high. Okay, but we will have the less ionization. Okay, so basically in this region what we have the ionized particles, positive and negative, positive and negative. Okay, so now when these electromagnetic rays, for example this is a dish antenna. Okay, now these electromagnetic rays when travel towards the above the earth surface, okay, so here we have different ions. So these ions, positive and negative ions, okay, they have their own electromagnetic fields. Okay, like positive ion has own electromagnetic fields, negative ion has own electromagnetic fields. So this electromagnetic wave which is coming, okay, so due to the high ionization layers here, okay, they will be reflected back. Okay, so they will face the reflection. Okay, and this reflection which actually depend on the ionization density in the region. Okay, if we have high density, okay, it will be then the reflection will be based on that. Okay, now if we have low frequency waves, so the low frequency waves are usually reflected, because they are low frequency, they will be reflected by the lower layers. Okay, and if we increase the like frequency, we are moving to the high frequency, they will be like they will penetrate the lower layers. Okay, because they have high frequency, but here we have the high ionization, again they will be reflected back. Okay, but what is happening here, if you focus, that as the frequency is increasing, okay, the coverage area is increased. For example, if you are transmitting from here with one dish antenna, it is reflected from here and it is coming back here. So you can cover this complete area. Okay, again, if you install one station here, you can cover this complete area. Okay, so depending on the frequency, we can control the coverage area for our propagation. So usually for the ground wave propagation is like, for example, you have installed one tower here and you have installed one tower here, okay, and they are we are working at very low frequency, okay, below 2 megahertz, okay, so they will just travel along the curvature of the earth, okay, they will not move towards the like these surfaces because they are low frequency. There will be continuously reflected from the lower layer. Okay, so this is the mechanism typically used for the AM radio broadcasting and also for the Navy, Marine. Okay, they have for the maritime radio propagation, basically radio propagation, they use this ground wave propagations. Okay, and it's usually work as the low frequency. Okay, and if you move towards the high frequencies, for example 2 megahertz to 30 megahertz, okay, so as I said earlier, so now we are moving towards the high frequency. Okay, so it will be reflected back by the ionosphere. So what is happening, we can cover the more area. Okay, with this we can cover the more area. For example, let's say this is Dubai, you are transmitting, for example, any information, for example a radio broadcasting, so it will be reflected and you can cover the area, let's say for example till Abu Dhabi, and then you can install another tower here, and with that tower maybe you can cover the area till Sharjah or maybe till Ras Al Khaimah. Okay, so if we move at the high frequency, our coverage area increases. Okay, so and the sky wave propagation, these frequencies are usually reflected by the ionosphere, which is actually around 90 to 250 miles above the earth curvature. Okay, so now the one question is that what is the criteria for the reflection of the waves? Okay, as I said earlier, the reflection of the waves, it depends on the ionization in these layers. Ionization density, that how much ions we have in that layers. Okay, so that term is basically defined as refraction index. We call this refraction index and it is defined like this. Refraction index, okay, refraction index tells us that how much layers are being reflected from the ionosphere. Okay, so it's 1 minus 81 times n over f square. N is the ionization density. What is the free electron density? And typically value is 10 to the power 10, very high density in ionosphere. F is the frequency. Okay, so depending on the frequency and depending on the ionization density, okay, the reflection index of the electromagnetic waves can be calculated. Okay, so if the ionization density is changing, okay, then the refraction index will be changing. Okay, and for example, if you move towards more high frequency, for example greater than 30 megahertz, okay, so at the 30 megahertz, what is actually happening? Okay, because we are moving towards more higher. Okay, so as we move more high, we know that here the ionization density is decreasing, right? The ionization density is decreasing. So with that, what we can do, we can cover more area. Okay, we can actually reach towards the satellites, okay, at the high frequencies. So here at the satellite, so we can directly communicate with the satellite and that. So the reflection become more lower, okay, as we move towards the high frequencies. Okay, so this is actually become the line of sight communication. Okay, and also we use this for the satellite. For example, this is one dish antenna, this is your second dish antenna, and let's say this is your satellite. Okay, so you can directly communicate. with satellite. Okay, there will be no reflection. Okay, because of the high frequency. So this is called line of sight communication, and this satellite can also directly communicate here. Okay, the satellite can also directly communicate here. Okay, so this is called line of sight communication. There is like they are directly communicating with each other. Similarly, on the Earth's curvature, as said earlier, okay, we have the towers, and we place the towers and we adjust their heights. Okay, the height of the tower, we adjust them so that they can directly communicate with each other in the line of sight. They're just looking at each other. Okay, without any issue. Okay, this is called line of sight communication, and usually it's done at high frequencies. Okay, because at high frequencies the refraction will be lower. And if you want to calculate, for example, if I install a tower here, okay, which has a height of h, then how much area it can cover, that this tower, how much area can be covered by this. Okay, like the distance. Okay, for example, if I install here and the distance between them is d, so will this tower will cover this region or not? Okay, so we can actually easily calculate that based on the radius of the earth. So we know that we have the radius of earth here, okay, which is actually r, and let's say this height is h. Okay, so this is the radius of r, and this is the height of the antenna, which is h. Okay, and we want to calculate this d. So using the Pythagoras theorem, okay, you can write that d square plus r square is equal to h square, right? Simple. And we know that usually like the radius of the earth is very large, right? So eventually what we can do, because the radius of the earth is much higher than h, okay, so we can make this more simplified. Okay, and eventually we can derive this relationship 2 times r of h. Okay, so by using this formula 2 times r of h, okay, we can actually calculate the distance, the coverage distance of the between two antennas. Okay, that is for the this part of the lecture. We will discuss the examples and the other topics relevant to this in the live session. Thank you very much for your time.